All right. Good morning, good afternoon, possibly good evening to everyone here. So my name is Rebecca Hartman Baker. I lead the user engagement group. You probably already know my name because I send you an email every Monday. Anyway, I'm going to do the welcome and the overview of NERSC for you today. So here's our agenda. So first, we're going to talk about NERSC. What is NERSC? And we're going to briefly talk about interacting with NERSC staff. So, NERSC is the mission HPC facility for the DOE Office of Science. And the DOE Office of Science is the largest funder of physical science research in the United States. There are kind of 6 sort of main areas of the Office of Science where they use NERSC. So, bioenergy and environment, computing, materials, chemistry, geophysics, particle physics and astrophysics, nuclear physics, and fusion energy and plasma physics. So at NERSC, we sort of have a dual mission. So we are advancing science, but we're also advancing the state of the art in supercomputing. So we collaborate with computer companies many years before a system's delivery in order to deploy advanced systems with new capabilities at large scale. So we were actually starting on Doudna, which is going to be our next machine, before Perlmutter came across the floor at NERSC. We provide a highly customized software and programming environment for your science applications because we want them to be able to run really well. We are also tightly coupled with the workflows of DOE's experimental and observational facilities, and we ingest tens of terabytes of data each day. So these are things like light sources, telescopes, things like that. And we also have a great staff that provide advanced application and system performance expertise to our users. Now, at NERSC, we have about 12,000 users, and they're from about 800 different institutions and national labs. As you can see, the largest plurality of our users are graduate students, and the largest institution type of our users is universities. But we have a variety of users in different stages of their careers and at different types of institutions. And from all these users, we get about 2,500 refereed publications per year that cite NERSC. Now, NERSC systems, we're always getting a new one every few years because, upgrades in technology and so forth. So anybody who's been around for a while may remember Cori, which was decommissioned in 2022. But now we have Perlmutter, and it is a machine that has CPU and GPU nodes, and we'll learn more about Perlmutter in a bit. And then our next system, which is set to arrive at the very end of next year, is called Doudna. And it's going to be our sort of exascale system here at NERSC. So we name our systems after scientists. And so Perlmutter was named after Saul Perlmutter, who shared the 2011 Nobel Prize in Physics for discovering that the universe is expanding and expanding. His supernova cosmology project was really a pioneer in that it used both simulation and data analysis and coupled those together. And so our machine Perlmutter is a machine that is great for both simulation and data analysis. And so that's why we wanted to honor Dr. Perlmutter and name it after him. He is still living, and so he asked us. We had to ask him, "Can we use your name on our supercomputer?" He said, "Sure, but one requirement: I feel like my last name is too long, and it's going to be hard for people to type. So you have to have another alias for the machine where they can log into sol.nersc.gov." It's only 4 letters versus, I don't know, 11 letters of his last name. So anyway, that was his one stipulation, and so we did that. So you can log into sol.nersc.gov or perlmutter.nersc.gov if you like to spell. Okay, so Perlmutter itself consists of many nodes, and each node is kind of like the equivalent of a really powerful desktop or workstation sort of a machine. So there are two types of nodes. The first type is the GPU nodes, and those contain 4 GPUs, A100 GPUs, and one CPU. And then then there are also CPU only nodes, and each of those contain 2 CPUs. And these nodes are combined into blades. So in one blade, we can have 2 GPU nodes or 4 CPU nodes. And you can kind of see the layout here in the middle. So you can kind of see, you divide down this line, those are the GPU nodes. You divide here, and those are the CPU nodes. Okay. These nodes, these blades, sorry, they stack sideways. They're up and down like this instead of normally you would see in a data center, they would be kind of flat like a pizza box, but our pizza boxes are 90 degrees vertical. And so they stack sideways into the server racks, into the chassis, and then each rack has 64 blades. And then you can see in this picture up here, each of these cabinets is one of these racks in it. And so that's what the system is made of. And in addition to, I've described the architecture of the processors and so forth. In addition to that, we have an all-flash scratch file system that's attached to the machine. And each of the nodes is connected to all of the other nodes through what they call a Slingshot 11 interconnect. And there are 4 network interface cards per GPU node and 1 per CPU node. And those cards are the things that control communication between nodes. So if you recall, this is kind of our nodes of what they're like. So we have 3,072 CPU only nodes, and we have 1,792 GPU accelerated nodes. Now, Perlmutter is connected to the outside world with a very fast connection to ESNet. And ESNet is another user facility of the Department of Energy Office of Science, but you can basically think of it as the ISP for the Department of Energy. And so we're connected to it at 1.6 terabytes per second, which is really, really big interconnect. So that's great. In addition, Perlmutter is also connected to other systems in our center. So we have different off-platform storage options, and you're going to learn more about these. Then later in other talks, you're going to learn more about these. But we have our HPSS tape archive, and we have our global common file system, and we have our, sorry, this is our community file system. And then we have home directories. In addition, we have other ways to access these storage other than Perlmutter. So we have DTNs, which is data transfer nodes, and we have gateways, so science gateways where you can view data that's been shared. And then we also have Spin, which is kind of an edge service that can provide a lot of really interesting features that you can use to access data or share data or do a wide variety of different things with Spin. And maybe we'll touch on that later, but there's a separate training all about Spin if you ever want to use it. Okay, I'm going to pause for a second here and mention that there bunch of people in the waiting room. So if we can let them in, that'd be great. Okay. So moving on. Any questions? Does anybody have any questions that you want to shout out? Otherwise, feel free to put questions into the Q&A doc. But if anybody has any questions, then I'm happy to answer your questions.
Someone asked a question about
Uh-huh.
applying for access to NERSC as a small business or a private lab access.
Mm-hmm.
Uh, Respond on that or?
Yeah, sure. So yeah, that's definitely possible. So we have, so if you are a small business that actually gets money from the Department of Energy, there is an allocation scheme for you. And so the SBIR office does get some time on NERSC that they're able to allocate. And they are really underutilized. So it would be kind of a slam dunk, actually, if you have that funding to be able to use those resources. If not, there are definitely other possibilities. And you can send an email to allocations@nersc.gov, and they will tell you everything that you ever wanted to know about it. The one catch, if you will, I don't think it's really a catch, but is that the work that you do at NERSC needs to be open science. So it needs to be something that's publishable. Even if you don't end up publishing it, it needs to be something that's publishable. So if you're doing something proprietary, you really can't do that on NERSC resources. But if it's something, like I say, that could be considered open science, then you are welcome to use NERSC resources. Okay, I think I will continue on unless you tell me there's another question. Okay, we'll go on then. Okay, so our next thing is about interacting with NERSC staff. So we're going to talk about my group, which is, of course, the best group at NERSC. And then we're going to talk about consulting and account support in general. So this is my group. We are 10 strong. We are very amazing people. Um, you you have already met some of them here or virtually met them. So Lippy and Charles, they are science engagement engineers in the user engagement group. Helen, who is also on, she is the lead of training for NERSC. And so um, then everyone else in my group does various other things. And we all are here basically because we love users and we really like helping you all and making sure that you're able to get your science done. Something I want to mention is we have the NERSC user group. We call it NUG for short. It's our community of NERSC users. It's a great source of advice and feedback for us at NERSC. We do really listen to them, and we're trying to, use the feedback that they give us to make NERSC even better for users. We have regular community calls. I should change that to say community calls instead of teleconferences. Community calls about approximately monthly on various really interesting topics. Lately, there have been some about using CUDA on Perlmutter, so I thought those were really cool. We also have, other topics like that are up and coming or relevant topics for what's happening now. We have, for example, the new allocation year is coming soon, so we'll have a call about that. And then we also have a Slack channel, and everyone is welcome to join that. And so that is the NUG Slack channel. It is not an official support vehicle for NERSC, but it is where you can talk to your colleagues and who are also using NERSC, and you can ask them questions like, "Hey, I want to do this. I'm having trouble with it. Can you give me advice?" Or you can ask them stuff like, "Hey, I'm having trouble to log in to Perlmutter. Is anybody else not able to log in?" Various things like that. And sometimes NERSC staff will make cameo appearances on the NUG Slack. But like I said, it's not an official support channel for NERSC. Okay, we also provide training. So we have a robust training program for users at all skill levels, interests, and different personas. So like the different ways that people are using NERSC. We record all of our trainings and then we get them professionally captioned and we post them to our YouTube channel. And we also post the slides to the training event webpage. There is a whole training events archive. And basically, if you want more information on upcoming and past events, you can go to our training webpage and find out more. Next, we're going to talk about interacting with NERSC. Oh, sorry, about our consulting and account support. So this is our consulting and account support team. So we have a whole bunch of people here who are supporting you. You may recognize some of these pictures, but we have additional folks from other groups who also do support. And the way that we primarily do support is through help tickets. And so if you go to help.nersc.gov, you will see this NERSC help portal. And so it has a few different things on it. It has a link to our documentation, which I highly recommend. Our documentation is great. I would definitely recommend going there first if you have a question. It's very thorough. Our documentation is, in fact, globally regarded, very highly regarded. I used to work in Australia, and if we didn't know the answer, we would look at NERSC's documentation, just so you know. Then there's also, like lists of like your tickets and open tickets from your project. And then there's also this open ticket, and that is where you will go to open a ticket. And we'll talk to you more about, best practices for tickets in our next talk. And finally, there's this one about opening requests. And these are requests for like an increase in your quota or a compute node reservation or a new database or that kind of thing. Okay. Another thing I want to mention is we offer user appointments. So in 2018, we began offering virtual office hours. So the idea is we're in a Zoom room, you stop by anytime to talk to us about a specific topic. Recent ones we've had are Perlmutter, we had a few of those this summer. And then ERCAP, we're having those right now, which is about allocation requests. And, we've had other topics. But one kind of shortcoming of this plan is that you get really variable traffic. So we'll go for hours with no one coming, and then we'll have like 10 people show up all at once. And so that can be a little frustrating for us, but also for the users. So another thing that we began offering in 2020 or 2021 was appointments, because those are kind of a really efficient use of everyone's time. So you can have a one-on-one appointment with a NERSC expert for 30 minutes and about a particular topic. And there's a list of topics that you can have an appointment about. Probably the most common one is called NERSC 101, which is just the basics of NERSC. And you can schedule an appointment at nersc.as.me. So take a look at that and feel free to schedule an appointment if you have any questions. So that concludes my talk here, and I'm really happy to once again welcome you to NERSC, and I'm happy to take any questions briefly before we move on.
I don't see any additional questions in the Q&A document besides the one that you asked about answered earlier. Do we have any other questions for Rebecca about NERSC resources, allocations, connecting? I guess you explained everything so well.
Obviously so. All right. Well, thanks everyone, and it was nice talking to you all.